This lesson is on similar triangles, so we're going to be looking at similarity rather than congruence. So similar is just another way that we're going to talk about proportionality. So similar triangles have proportional sides. And they have congruent angles. So unlike a congruent triangle, which would have congruent angles and congruent corresponding sides, similar triangles have congruent angles but proportional corresponding sides. So side similarity is similar to side congruence in that it involves all three sides, but this time we're not talking about it being congruent, we're talking about being similar or proportional. So when I look at this, I know that RP, segment RP, is going to be similar to KD because those are proportional. So 24 over 72, and I can divide by 12, and that's going to be 2 over 6. Or 1/3. So basically we have a scale factor of 1/3 if we're going from KDC to PRC. And then we know that DC would be similar to RC. And that's 13 over 39. Well, that's 1/3. And then we have KC is similar to PC. And that's 18 over 54, which again simplifies into 1/3. I could divide that by 18 and get 1/3. So here they all simplify down to 1/3. So I know that it's proportional, and every set of corresponding sides is proportional by the same rate. So that's going to be side similarity. And another way to say that would be that we have a scale factor of 3. So to go from the smaller triangle to the big triangle, we multiply all those side lengths by 3, and we can multiply all of them by the same thing, and that tells me that it's proportional or similar. So our similarity statement here would be that KDC, triangle KDC, is similar to triangle PRC. Next, we have angle similarity. And this is just saying that if two of the angles in a triangle or in two triangles are congruent, then they're going to be similar triangles. So here we have vertical angles, so I know that those are congruent, and that means that at least two corresponding angles in each triangle are congruent. But I also know that if two of the angles are congruent, then the third one has to be congruent too, because a triangle has to equal 180 degrees. So if two of the corresponding angles are congruent, then the triangles are going to be similar. They're not always going to be congruent because the side lengths can still be different, but they will be proportional. And then side angle side similarity is going to be where we have two sides that are proportional and that included angle that's congruent. So when I'm looking here, I know that this total from D to N is 72, and from D to Q is 18. So that's 18 over 72, or 1 over 4. So this is a proportion of 1/4, and we want to see if the other side is also a proportion of 1/4. So 13 over 52, which is also 1/4. So I know that these two sides are proportional. And then this angle in between, angle D, is included and has to be congruent because it's shared by both triangles. So that would be side angle, side similarity. Now I want you to try these examples, and then we will talk about them. All right, looking at example 1, we want to know if the triangles are similar, and we've got this angle right here, angle Z and angle W, that we know are going to be congruent. We don't have any side lengths, so at this point our only option would be angle, angle, and that will work because we have this shared angle right here. So those are similar based on angle, angle, and the statement would be that ZXY is similar to triangle WXV. Now looking at number 2, we don't have very much information marked, but we know that this angle in the middle is going to be congruent. And we know that JK is parallel to GF. Now, because they're parallel, we can treat this like a transversal. And in a transversal, we know that alternate interior angles are congruent. So then angle K is also congruent to angle G. So this one would also be angle, angle. But that one is a little bit more complicated. And our congruent statement would be that KJH is similar to GFH. Now you can go ahead and try example 3 and example 4. Looking at example number 3, we've got this side, and 4/6 is 2/3. We've got this side and this side. 6/9 is also 2/3. And we've got a congruent angle in between them. So that's going to be side angle, side similarity. And our statement would be that triangle LNM is similar to triangle QRP. Now when I look at example 4, this one's a little bit different. So I've got LKM right here, but they did not give me the total side lengths for ELJ. So 6 plus 3 is 9, so I know this whole side is 9, and this whole side is 15. I know I'm going to have a congruent angle because they share it. So for LK, I've got 6/LE, which is 9. So that's going to be 2/3. And I've got 10/15, which is also 2/3. So I know that the sides are proportional as well. So I know that this is going to be side angle, side similarity. And I know that triangle KLM is going to be similar to triangle ELJ. Now you can go ahead and try number 5 and number 6. Now when I look at number 5, I have to be careful because QR is actually corresponding to NO. So I'm going to be looking to 7/21. And then I've got 15 is corresponding to 45. And 12/30. and I want to make sure that they can all simplify to the same thing. So 7 over 25, or 21 would be 1/3. 15 over 45, also 1/3. But 12 over 30 is not going to be 1/3. If I divide 12 by 2, I get 6. 30 by 2, I get 15. 6 by 3, I get 2. 15 by 3, I get 5. So these are not similar. Now when I look at example 6, I want to fill in some information first. I know that if DL, this whole side right here, is 88, then KL has to be 32, because 56 was used for KD. And I know that LM has to be 52. So that will help me fill in my sides. So I want to know if 32 over 88 and 52 over 143. And then I know that I have a congruent angle because it's shared. Now this is going to end up being 4 over 11 if I divide by 8. And the bottom one also ends up being 4 over 11 if I divide by 13. So this is going to be side, angle, side, similarity. And our statement would be that triangle DLE is similar to triangle KLM.